complex numbers, and you've seen some transformations, I will explain some of the objects I've been studying closely. Here you see a number of points. Some are blue inside the unit disk, and some are yellow outside. Let's perform the transformation z² several times, and let's look at the result. You can see that the blue points stay inside the disk, and the yellow points, on the contrary, escape from the disk, and even escape from the screen. One says that the blue disk is the filled-in Julia set of the transformation z². Points outside the Julia set escape to infinity when one repeats the transformation indefinitely. But we can play the same game with other transformations, like for instance those of the form z² plus c, where c is a complex number that we can choose at will. For each complex number c, we therefore have a Julia set whose shape changes when c changes. You can see a few examples here. Here is the one I called the rabbit. In order to understand how these shapes change, I will show you several things in parallel. On the left-hand side, the red side, you can see a point that will start to move. This is the point C. On the right-hand side, you see the corresponding Julia set. This is deforming as C slowly changes. But sometimes, for some values of C, the Julia set seems to disappear. One cannot see anything anymore on the screen. Like now, for instance. The truth is that the Julia set blew up into an infinite number of pieces so small that you don't see anything on the screen. Benoit Mandelbrot, who popularized fractal sets, suggested the study of this set, drawn in red, that describes the values of C, for which one can see the Julia set clearly on the screen. In other words, those for which the Julia set did not blow up into multiple pieces. Of course, this red set is called the Mandelbrot set, and I spent quite a lot of time studying it. To finish, I suggest that we look closely, very closely, at this Mandelbrot set, and zoom inside so that you can appreciate how beautiful it is. Let's go. Here it is. Admire. For once, I will not explain everything. Imagine the Mandelbrot set as a black island, surrounded by a tropical sea, and that you can see the bottom of it. Really, you are looking at truly microscopic details. If the Mandelbrot set were the size of a soccer field, well, we would be looking at details the size of a single atom, of the order of a millionth of a millimeter. Maybe you're wondering why I got interested in this. First of all, because it is beautiful, and because understanding these objects gave me much pleasure. For me, this is reason enough to spend time on these questions. But also because in these transformations that look so simple, one can find the essence of chaos, such a fundamental concept in modern science. Simple things generating rich structure. To study complicated phenomena through their simplest incarnation, this is often the role of the mathematician.